Hey, I'm Kevin, and I lead product at OpenAI.
Hi, I'm Michelle, and I'm a post-training research lead here at OpenAI.
Hi, I'm Ishan, and I also work on post-training.
All right, today we're excited to announce GPT 4.1, which is a family of models in the API that were trained just for developers. And it's three models. So it's GPT 4.1, GPT 4.1 Mini, and for the first time, GPT 4.1 Nano, which is our smallest, fastest, and cheapest model ever. Now, these models are better than GPT 4.0 on just about every dimension. They even meet or beat GPT 4.5 in a bunch of key ways. And for the first time, they have long context. So all three models, even the Nano model, can handle up to 1 million tokens of context. We've also got some fun pricing stuff to talk about, but we'll save that for later.
And actually, the decision to name these 4.1 was intentional.
I mean, it's not just that we're bad at naming.
It's not just that.
It's also that. But these models are better across the board. They're great at coding. They're great at complex instruction following. They're fantastic for building agents. So let's dive in. Let's talk evals. Let's do demos. You want to take us away?
Yeah. Let's get started with a little look at kind of the intelligence by latency curves here. And the the 4.1 series actually improves a lot from 4.0. So you can see 4.0 and Mini here are in green. And then 4.1, we have these three new models that kind of move that frontier upward because they're much more intelligent. You also can see that we have Nano as a new entrant in this area, and it's much faster, but also, really holds its weight on intelligence. So that's kind of the rough shape of the models. And, when deciding when to use them, we recommend starting with 4.1, and it's our kind of powerhouse for these three dimensions: coding, instruction following, and long context. But if you need something a little faster, for maybe a slightly simpler use case, I'd recommend 4.1 Mini. And then finally, Nano is just an absolute workhorse for tons of applications like autocomplete or classification or extracting stuff from long documents. So that's kind of when you should use each model. But let's get into coding first. So developers care a lot about coding, and we've been improving our model's ability to write functional code. And so what does that mean? We've been working on making it follow diff formats better, explore repos, write unit tests, and write code that compiles. And actually, SweBench is a really great eval for evaluating this sort of performance. The model is dropped into a Python repo. It's given a task. It's got to explore, write some code, write some tests. And we see that GPT 4.1 is a significant improvement over our past models. It reaches 55% accuracy, up from 33% from our previous GPT 4.0 model. And we think this is pretty impressive for a non-reasoning model. It even beats 0.1 and 0.3 Mini. But SweBench is all Python. And we've also improved this model's ability to code in other languages. And Aider Polyglot is a great benchmark for that specifically. It's got a bunch of languages. But also what's cool is that it's got a whole and diff format. So sometimes developers want the model to rewrite the entire file, but sometimes you want it to produce diffs. And that's useful when you want a faster application. You save latency on the tokens that are not changed.
Also save money, right?
Exactly.
Yeah.
And so here you can see that we've really closed the gap on whole and diff performance. And we've also doubled GPT 4.1's diff performance from 4.0. You can also see that Mini is a really significant improvement over GPT 4.0 Mini. So we think both of these models will be a great model for any kind of coding tasks. So those are coding benchmarks. But there's also kind of the intangibles of when you're using a model. When you're creating a front end, is it functional? Is it beautiful? Does it nail the mark? And so for that, we have a little example of a flashcard app I've been making.
You're learning Hindi.
Yeah, working on it. And so I've got a prompt here. It's pretty complicated. I'm asking for this app pretty specifically. I want a nice 3D animation when you click on the flashcard. And so when I give this prompt to GPT 4.0, this is what I get. It follows some of the instructions, and some of the app is functional. But we've really trained GPT 4.1 to do better. And that model, you can see it looks way better. It's discovered colors. It can also do the 3D animation. So we think you're really going to like this improvement to front-end coding.
And this was just based on that prompt that you gave it?
Just one prompt, and you get back an entire working application. It's pretty cool. But we've also been working on instruction following. So can you tell us a bit about that?
Yeah, so just like coding, we have made the model way better at instruction following. It now strictly follows all the instructions that you provided. So using all the feedback that we received, we created this internal instruction following eval, where it mimics how an API developer uses our model. So each sample in the eval contains a complex set of instructions, where each instruction belongs to one of several categories, like formatting, ranking, ordered instructions, overconfidence, and so on. And collectively, that sample is given a difficulty rating from like easy, medium, and hard. And we see that this model does really well across all those axes and on difficulty levels as well. So here you can see the hard subset eval results, and this model is so much better than the previous 4.0 model.
So what's an example of like a really hard set of instructions to follow?
Yeah, so let's say you're building a trip planning application, and you give it instructions like make sure you receive all the info from the user before answering them. And when you answer with the trip itinerary, make sure it's in a table format. It contains 5 rows, 3 columns. The columns are formatted in a certain way.
Yeah, I don't know about you all. I remember all the times that you learn these tricks in prompting where you're like, no, you really need to make this a table, not a list. Trust me, my boss is going to be super mad at me if you don't get this right. Yeah, so hopefully no more of that.
Yeah, and people actually were doing that just so that they could get the model to follow an instruction. None of that is needed now. The model follows all your instructions to the T, and it does really well. We also have a new prompting guide now that we'll publish on how to get the best out of our models.
Awesome.
And not just internal evals, even on external benchmarks like Scale's multi-challenge eval that tests models' instruction following capabilities on multiple turns, our model does really well. So for example, you might have an instruction 3 turns ago, and it tests whether the model remembers that instructions and continues to follow it. So it also tests models' coherence and memory. These improvements also scale well on long context data too. So you could give it large corpus of data, and the behavior that you're trying to extract from the model, it'll continue to follow that.
Nice. Yeah, speaking of large corpuses, GPT 4.1, Mini, and Nano are our first models to have 1 million of tokens in as the context. This is up from 128K for our past models, so it's an 8x improvement, which is pretty big. But it's not enough to just have the context. You want the model to be able to use it effectively. And so for that, we're showing this eval we created, which is a needle in a haystack. We insert some kind of text into a large corpus, and we ask the model to find it. And we see that the model can find it across any depth, so maybe at the beginning, the middle, or the end of the document, and also across the entire full length of the context up to 1 million.
This is a very boring looking graph, but it's boring in a great way because it says every square is actually working.
Yeah, it's actually boring through so much work, which is so cool. Normally you would expect to see some of these be red, like the long context doesn't hold up to a certain area, but the fact that all of these is blue means that the model can find what you're looking for.
And this is for all 3 models?
All 3 models, even Nano. So this is not, the end-all be-all of long context. It's nice to find a detractor in a long document, but that's not exactly what all our developers are doing. So we've also created an eval called OpenAI MRCR, and this is a kind of more challenging way of determining how well the model does on long context. So you can see that GPT 4.1 in blue exceeds GPT 4.0 in green significantly, up to 128K tokens. And it holds up quite well all the way up to 1 million tokens.
And this eval is actually really complex. Can you explain a little bit more about how it works?
Yeah, it's pretty complicated. So we basically create these synthetic conversations where there's a user and an assistant talking back and forth. And the user is asking for things like, give me a poem about tapirs, and then give me a poem about frogs, and then maybe give me a short story about tapirs. And then we ask the model, find me the second short story about tapirs. And so you can find it's pretty complicated. You have to not get confused by the poems and the frogs and find the second and not the first one. So we're really excited about this improvement in performance, but you can see that there's still some work to do here. And so as part of that, we're publishing this eval on Hugging Face today, OpenAI MRCR, and we really want to spur on more work in the kind of more difficult long context processing area. Yeah, and then more on multimodal long context. So sometimes you're not just using text, but you also want to upload a video. And we found that on the video MME benchmark, GPT 4.1 reaches state-of-the-art performance, achieving 72%. So this benchmark is pretty cool. You upload like a 30 to 60-minute video without subtitles, and the model is asked multiple choice questions. So GPT 4.1 is much better at understanding this sorts of thing. All right, and then one last hit on evals, a lot of plots, I know. On multimodal processing in general, these models are a really significant improvement. But the real story is GPT 4.1 Mini. This model, you can see it really punches above its weight on multimodal reasoning and intelligence. And we think this is probably the top model to be used if you're doing any sort of multimodal or image processing.
Okay. Amazing benchmarks, but let's see some demos.
Let's do it. So here we have the OpenAI Playground, which is a really nice UI to iterate on OpenAI's APIs. I've pre-selected the latest 4.1 model. And in the system message, I've given it a light identity. The identity is it needs to produce a single Python file code application with very limited setup required. I also told it that it has access to the latest 4.1 model, which can handle up to 1 million tokens of input and 32K output. So on the right, we mimic a user query. So the user is asking to make a website that can take a large text file and answer questions about it. We give it very limited style guidance, and we tell it to use OpenAI's responses APIs to answer questions about the doc. So let's see it in action.
So you're having, as part of the demo, you're having it create a website, and then you'll use that website for the rest of the demo.
Exactly.
Okay.
Yeah. So now it's producing like multiple hundreds of lines of code. I've rerun this query before, and I've copied the code that it spits out into this app.py file. So you can see it's a multiple 100-line file. You see that the HTML has been inlined in this file. If you keep scrolling, you would see there's an upload code, the code to ask questions. It's going to hit the responses API.
So the model did this just in one shot?
Yeah, it's doing that right now as you're seeing it. Yeah, it does produce the code. It tells you how to spin it up.
Cool.
Yeah. Should we take it for a spin?
Let's do it.
Yeah.
Cool. OK. So let's try.
Nice.
What do you think?
That looks pretty cool. It's a little BDB sassy, but I think it's working.
I do like that it advertises itself there at the bottom, powered by GPT 4.1.
Yeah, it's kind of neat. Just based on the limited guidance that we gave it, it produced this website. So to test the log file that I'm about to upload, that file is NASA's server request response log file from 1995 August. Let me show you that file.
You just have this file lying around?
Yeah, you don't?
I prefer the 94.
Oh.
The 94 is a great version.
That's a good one, yeah. So in this log file, you can see the client name in the left that made the request to NASA's servers. You see the timestamp, the resource that was accessed, and the HTTP response code. This is a long file that contains a lot of log lines. And you can see on the left that this is about 450,000 tokens of content here.
Nice. So you just couldn't use this with our past models?
Yeah, this wasn't possible. So let's try uploading this file. Now what I've done is I've snuck in a line that is not actually an HTTP request response. Let's see if it can find it.
Very sneaky of you.
OK, so it's a little needle in a haystack, except in this case, you don't even tell it what the needle looks like. It's just figure out what's different and tell me.
Exactly. So it's going to sift through the whole file, do some pattern matching to see how all the log lines look like, and then try to see if there's one that does not look like the others.
Nice. And I really like this thinking spinner. So this is just the front end that we created in the demo right before this one.
Exactly. It's like a nice actively going spinner. And all the front-end improvements also are showing up here, even in this like very limited single-page Python application that we asked it to write. It doesn't have access to like other additional files that it could spit out for styling or anything like that. So
totally. Yeah, I think this front end is definitely significantly better than one I can make. So it meets my bar for sure.
Yeah, yeah. And this spinning thing is kind of neat.
Definitely taken a sec, but I think we're almost there. Any minute now.
Come on, 4.1. Live demos are awesome.
OK.
We made it.
OK, there is a line that it has spit out that does not look like an HTTP request line to me.
It does not.
OK. Let's see if this line is indeed in the log file that we uploaded. I'm going to copy this keyword.
Nice.
Yeah.
There it is.
Great. So it was able to find this line that has been snuck into this deep 450,000 token log file that is like very hard to find. So did pretty well.
Nice job, GPT 4.1.
Let's look at another demo.
Awesome.
Okay. So here we are going to riff on the previous demo that we saw, but this one is going to be more focused on how an API developer prompts our model. So I've again selected the 4.1 model here. And here the application's personality is of a log analyst assistant. We tell it how the input data will be structured. So we tell it will be within these log data tags, and how the user's query would be structured. So that would be in the query tag. And then we have a set of rules. So these are kind of the instructions that an API developer would provide to the model. So they are saying that only answer questions about the content within log data. The question should always be formatted within the query tags. If any of those things are not true, please respond with an error message. The response should be in an XML format, and I've given it some very light guidance on how the XML format should look like. So it should have some tags like result, final answer, references, and so on.
Nice. Yeah, this looks a lot like the system messages we find developers use often. You know, they're pretty meaty.
Yeah, and I've preloaded the log file here. So this is the trimmed version of the same log file we saw earlier. Cool. So I first made a request saying how many requests were made by fnal.gov. And it rejected it because it was not formatted within the query tags. Now I'm going to make the same request within query tags and see how it does. OK, now it was able to find the two references that are within the log file. So this is the kind of interaction we see quite a bit with 4.0, where users want a certain behavior, and especially certain behavior not to happen, and the model sometimes misses on it. So I have an example. I made the same query to 4.0, and it answered the question instead of saying that it needs to be wrapped in query tags.
Yeah,
So, yeah.
That's a key detail we hear a lot from developers. You really want it to follow negative instructions and do exactly as specified.
Exactly, yeah.
Super cool.
Awesome. So great results on benchmarks. That was an awesome set of live demos. I know a big amount of work has gone into just making sure that this model is really good at the kind of day-to-day tasks that developers face. And you and your team have put a ton of time into that, so maybe talk a bit about it.
Yeah, totally. Yeah, it's not an accident that developers in the real world love using these models. To that end, we kind of went with a data sharing program last year where developers can opt in to share their traffic with us in exchange for free credits. And so when that traffic comes in, we'll scrub it for PII, remove any identifying details, and then use that to improve our models. And actually, one of the key things we do with that is creating evals. And so the evals help us tell, like, when we're creating a new model, are we on the right track? Are developers going to like this? And so the eval Sean mentioned at the top, instruction following, was directly inspired by this. And so first I want to say thank you to all of the developers who've opted in. Thanks to you opting in, we've been able to make a much better model. And then what I'll say for developers who haven't yet, if you want the models to get better for you with no work on your part, I'd recommend opting in.
Yeah, it really does help us build great models for you. Now, we said we also would come back and talk pricing. Our mission is to ensure that AGI benefits all of humanity. And one of the things that we've learned over and over is that the more cost effectively we can offer our models, the more use cases you're able to build, the more that you're able to use AI to help people all over the world. And so in particular, GPT 4.1, with all of the improvements that Michelle and Ishan have been talking about, is going to be 26% cheaper than GPT 4.0. And GPT 4.1 Nano is our smallest, fastest, cheapest model ever at just 12 cents blended per million tokens. And going beyond what any of our competitors offer, there is no pricing bump for long context. So when you use our long context models, you're just paying for your tokens the same way that you pay for a non-long context request. Now, one bit of a fun police update here. We know GPUs are at a premium. We want to make sure that we can get GPT 4.1 out as broadly as possible to all of you. And we've just been talking about how 4.1 beats even 4.5 on a lot of key benchmarks. So we're announcing that we're going to be deprecating GPT 4.5 in the API. Not today. It'll happen over the course of the next 3 months or so. But we really do need those GPUs back.
Yeah, we're really excited to get some back for research, so thank you.
Yeah, and I know we all love GPT 4.5. A lot of the improvements that we've made are going to continue on in this model and in other models, so it has been a very successful experiment. Now, we have one more surprise for you. I'm really excited to invite Varun, who's the founder and CEO of Windsurf, which is one of the premier agentic coding IDEs out in the market. Varun and his team have been early testers of GPT 4.1, and excited to hear from you directly. How's it been?
Yeah, we got access to GPT 4.1. We were super excited to sort of test it out, and we were very surprised with the performance. We have internal benchmarks that are very similar to what a SWE bench looks like that validates end-to-end software performance, and we found that it was a 60% improvement over GPT 4.0, which is a massive bump. But internal benchmarks only tell a part of the story, right? For our users, what matters more than just getting to a solution, it's actually the smoothness, the interactivity when you're vibe coding an app or modifying an app. And what we actually found was GPT 4.1 has substantially fewer cases of degenerate behavior. And maybe a couple examples here, we found that GPT 4.1 reduces kind of the number of times that it needs to read unnecessary files by 40% compared to the other leading models. And also, it modifies unnecessary files 70% less than the other leading models. To top it all off, the model is also surprisingly less verbose, right? These models sometimes tend to blabber a lot, and GPT 4.1 is 50% less verbose than the other leading models as well. For all these reasons, we've been super excited about the performance. We decided to actually go out and provide GPT 4.1 for free for all of our free and paid users for the week, and also heavily discount the product immediately afterwards.
So just to recap, in Windsurf, GPT 4.1 will be free, totally free for the next 7 days, and then going forward will be heavily discounted for a while.
That's exactly right.
Awesome.
Amazing.
I will say this weekend, my 8-year-old decided he wanted to start selling Legos. And so we opened up Windsurf, opened GPT 4.1, and we vibe coded a Lego website for his upcoming business. And it worked great. So,
Nice. You'll have to send that over.
Yeah, we'll post it with the live stream. I'm sure everybody is excited about it. But thanks so much for joining us. We're super excited to see what people build in Windsurf and in beyond. So that's today. We have a family of 3 models, GPT 4.1, GPT 4.1 mini, and GPT 4.1 nano, that are our smartest, fastest, cheapest models that we have ever built, just in the API for developers. By the way, you can also fine-tune GPT 4.1 and 4.1 mini starting today, and nano will be available to fine-tune in the near future. I want to say a huge thank you to Michelle, to Ishan, and to their whole teams. These models are fantastic. We're super excited to see what you all build. So that's it for today. These models are available now. They're in the API. Please start using them. We can't wait to see what you build, and we look forward to hearing your feedback. Thank you so much.